Okay, in the today's class I am going to discuss about SR flip-flop using NOR gates. So SR flip-flop using NOR gate is obtained by connecting two NOR gates back to back as shown here. So here there are two inputs are there, S and R, two outputs are Q and Q bar. This is a logic diagram and this is a logic symbol. R and S are the two inputs, Q and Q bar are the two outputs. R stands for reset, S stands for set, Q is the output, Q bar is complement of Q. In the sense, if Q is 0 means Q bar is 1, if Q is 1 means Q bar is 0. So here in this diagram we are using a NOR gates, that's why you should know the truth table of the NOR gate, right? This one we already studied, the truth table of the NOR gate, right? If both the inputs are 0 0, then output is 1, otherwise the output is 0. Then when we call flip-flop is in set state means if Q is 1, then the flip-flop is in set state. If Q is 0, then it is in reset state. Q means output. If Q is 1, set state. If Q is 0, it is reset state. That's what I written here. If the flip-flop is in set state means the Q should be 1. Reset state means the Q should be 0. Okay. So this one I already told you, when both the inputs are 0 in the NOR gate, then only the output is logic high. Okay. So now you should get this table. Okay. So now we have to analyze the 4 cases, case 1, case 2, case 3, case 4. Okay. First we start with case 1. When both the inputs are 0 0, the output is previous state output. Means output won't change. Output remain same as the previous state output. Okay. How in the sense? We will analyze it. The first case is when S is equal to 0, R is equal to 0. Case 1, when S is equal to 0, R is equal to 0. Okay. So these are two tables for the NOR gate. So what I will do, initially I will assume that the previous state output at Q is 1. The previous state output at Q is 1, and obviously the Q bar is 0. Previous state output. And at S is 0, and R is 0. Okay. And this 1 will be come here, appeared here, and this 0 will be appeared here. Okay. You have to look first digits. Okay. So if you have input 0 and 1, the output is 0. The output is 0. Same as previous state output. Right? Then you look here. If inputs are 0 0, then output is 1. Then the output is 1. 1 means you already have your previous statement. Okay. So that is one case. If I assume Q is 1, Q bar is 0. Suppose if I assume the second digits, we consider second digits at all the inputs and outputs. Okay. In the second case, what I will assume, at Q I will assume as 0 as previous output. Q bar, obviously the complement of this one, it will be 1. At S and 0 R, you have 0 and 0. Second 0, 0. So here you have 0. That 0 will be appeared here. Here you have 1. that one will be appeared here. Okay, then if both are zeros, then the output is 1, 1 0, then the output is 0. What does it mean? In this case also the outputs are retained as in previous state output. Therefore, in the truth table of the SR flip-flop, what I written here, if both S and R are 0 0, if both S and R are 0 0, then the outputs are Q and Q bar, previous state, right? Then the outputs are previous state. Is it clear? I hope you understood this first step. Next we'll come to the second. If you come to the second case, S is equal to 0, R is equal to 1, we have to give. This is for case 2. S is equal to 0, R is equal to 1. S is equal to 0, R is equal to 1. Okay. So in the not true table, you might observe here, if any one of the input to a NOR gate is 1, if any one of the input to a NOR gate is 1, then the output is 0, right? So here for gate 2, one of the input is 1, therefore what is the Q here? Q should be 0. Okay, if Q is 0, that will be fed here, the same this 0 will be appeared here. If both are 0 0, then output is 1. That same one will be fed here. If both are 1 1, then output is 0. Here in this case, we are getting Q as 0, therefore the flip-flop is reset. Okay. Next, that's why when S is equal to 0, R is equal to 1, Q is equal to 0, Q bar is 1. Reset. S is equal to 0, R is equal to 1, Q is equal to 0, Q bar is 1. 0, Q is 0 means reset. Next, we will discuss about the third case. S is equal to 1, R is equal to 0. If S is equal to 1, R is equal to 0. Similar to the previous case, if any one of the input to any one of the gate is 1. So here for gate 1, the input is 1, irrespective of the second input. Here the input is 1. And what will be the output? If any one of the input is 1 means the output is 0. Q bar is equal to 0, write on here. That 0 will be appeared here. 0 0, 0 0 means 1. So 1 you have to write it here. So this 1 will be appeared here. So 1 1 0. Here Q is 1, Q bar is 0. Q is 1 means it is set state. Your flip flop is in set state. Therefore, for S is equal to 1 and R is equal to 0. For S is equal to 1, R is equal to 0, Q is 1, Q bar is equal to 0. Q is 1, Q bar is equal to 0. Okay. Then last case, when S is equal to 1 and R is equal to 1. Okay. So according to this truth table, here I put S is equal to 1, R is equal to 1. From this truth table, you might observe if any one of the input is 1, the output is 0. Right? So in this case, both the inputs are 1. But in the previous case, any one of the input is 1, right? Among two gates, any one of the input is 1. But here, both the inputs are 1. Then, if both the inputs are 1, both the outputs are 0. But this is not possible because if Q is 0, Q bar should be 1, or Q is 1, Q bar should be 0. This state we call it as forbidden state. Okay, this state we call it as a forbidden state. So that's what I written here. So S is equal to 1, R is equal to 1, Q and Q bar are 0, 0. That state we call it as a forbidden state. So finally I can conclude that this is the truth table for the SR. If you have any doubt you can call it.